far. And of course, nowadays we're especially interested in getting all of the operational visibility and data visibility around the network traffic and information that we store in CockroachDB. So that's yet another big topic for us. We're very happy to have Patrick. He came from Kaiserslautern. That's somewhere, you would say, in the countryside. So thank you for being here.
All right, I know it's late, and I get it that sometimes it's hard to get people excited talking about databases. So my intent today is to get everybody on the same page. What is Cockroach? Why do we even exist? And why it's maybe good to dust off your Postgres, your MySQL, etc., and consider looking into new modern cloud-native technologies, even though they from time to time tend to be a little bit dry, but hopefully I can spark that interest with some of the, let's say, key capabilities that makes Cockroach unique at the end of the day. So to, let's say, paint the picture, where do we fit in this grand landscape of databases? So on the left-hand side, we have the relational databases, your Oracles, Postgres, MySQL of the world. And they're pretty known for their reliability. They're still used in the most critical application in the world for payment processing, risk management, financial ledgers, all that kind of stuff. Metadata, so everywhere you basically process transactions where accuracy of the data is key. On the right-hand side, we have the NoSQL databases. And they're loved for their scalability, because all of a sudden you add more machines to it, and you can horizontally scale. You get more capacity, you get more performance, more throughput. You get more resiliency, because you all of a sudden replicate your data set across a fleet of machines and not just a single instance of a database. So they provide a more flexible model. But as you can see and probably know from your own experience, it's a different type of database. So it's a NoSQL, it's a document often, and we basically bring together the best of both worlds. So we give you still the relational nature of a database. So you would interact through a SQL interface with CockroachDB. You still get the reliability, the consistency, but all of a sudden you get also the scalability and the resiliency of a NoSQL database. And that combined with a cloud, let's say, architecture, so that you can either consume it as a managed service on all of the 3 hyperscalers of your choice, or if you choose to run it maybe natively on Kubernetes in your own data center. So that's what we mean, managed and flexible, basically, because you can pick and choose where it's the right place for you to run your database. And Kubernetes, for instance, is one of the places where we support running a database. All right, let's dive into it a little bit deeper. What is CockroachDB? So CockroachDB is a distributed SQL, a cloud-native distributed SQL database. It's written from the ground up, so we have not taken like Postgres and ripped and replaced some bits and pieces here and there, which is typically what you would find on some of the major cloud platforms as a managed service offering. So we literally built it from the ground up. But we've made a couple of key decisions in order to make it easier for people to adopt the product. A being that we align ourselves with Postgres. That means from a SQL dialect, we try to achieve a high level of compatibility. So if you're running on Postgres today, so that A, the learning curve and the migration efforts are minimal coming over to Postgres. And that means not only that we use the same dialect, or a similar dialect, you could say, we even use, for the most part, the Postgres drivers. So for your application, it will look and feel like it's connecting actually to a Postgres database, while it's actually connecting to a distributed database consisting of a fleet of machines. So the minimum would be 3 machines, and from there on out, you could scale to any numbers, and we'll get to that in a minute. But by now, or as of today, basically, the days are gone where you have a single node that's handling reads and writes, where you need to worry about the replicas. Can you run them in sync replicas? Do you need to do like async replicas, etc.? All those worries are gone. You're always talking to a distributed system, and your data will be distributed across the fleet of machines. A key takeaway is that we still maintain the asset compliance so that we can be used for the most critical workloads. No matter, I mentioned a couple of, let's say, spaces we're heavily used in, like the financial sector, when it's about payment processing, financial ledgers, and all that kind of stuff, or identity and access management, for instance. So then let's talk a little bit about scale, why companies look at CockroachDB when they kind of get stuck with, let's say, their Postgres instances, is that with CockroachDB, it's as easy as adding nodes to the system. Now, if you're running on Kubernetes, for instance, it's as easy as bumping up, let's say, the node count in your stateful set, and we take care of the heavy lifting under the covers. That means as soon as you add more nodes to your system, that will be automatically discovered by the rest of the existing nodes. We will reshuffle the data around, so there's no manual operation to that. B, that's probably the biggest takeaway when it comes to scaling, that in CockroachDB, all the nodes are active at the same time. They're basically all the same. There is no particular node that stands out as the node that can read and write or has certain, let's say, features and functions. They're literally all the same. And all nodes can read and write to the dataset at the same time, which means that you can push quite a lot of transactions through the system, which is one key reason customers look at us. If they, just a couple of days ago, I spoke to a customer that says, hey, every time we are going, let's say, beyond, for their case, it was like 6,000 inserts per second, it just falls apart. So, and that's when it's time for them basically to look at how can they put in a database in place that can scale along with their demand, being it seasonal peaks, where you have maybe things like Black Friday, Cyber Mondays, Christmas season, et cetera, coming up, where you as a provider need to make sure that your system can scale along with the demand. Or if you're launching a new service maybe and you have no clue how it's going to be adopted by your customers, by the community, and you need to scale over time, that's a perfect case where you can basically start small and scale along from a database perspective. But biggest takeaway, if you remember one thing when it comes to scaling with CockroachDB, you can scale horizontally, you can scale reads and writes, and it can be done online. That means from, let's say, Kubernetes perspective, or even if it's our managed service on the cloud, you hit the right API calls or push the right buttons, you can scale the system while literally now, so to speak. So you don't have to schedule downtime at like 2 a.m. in the morning or on a bank holiday just to do some maintenance activities. That can be done basically online. And you can also scale back in if needed. Talking about the seasonal peaks, maybe you just want to overcome some of the seasonal peaks and then scale back in. It's basically the same process, just decrease the node count at the end of the day. Scaling for us means not only pushing more performance, more transactions through the system, it means also where you actually can put your nodes. So you're not limited to placing all of the CockroachDB nodes in a single bucket, single, let's say, availability zone. You can start small, single cloud, single region, multiple availability zones. But maybe over time, your business requires more resiliency. And that's the point where customers that have their own, let's say, zero downtime initiatives that want to overcome even downtimes from, let's say, hyperscalers, and downtimes happen from time to time, we help basically to stretch the database layer across multiple physical regions. And the system is designed to handle latency in between those regions. So you're not limited to a particular area. Technically, you can even stretch it across the globe and place a couple of nodes, let's say in the North American region, European region, and APAC region. The system is designed to handle that. Ultimately, it's about what you're trying to achieve from an application, from a use case perspective, and how much latency you can handle. But the database is designed to do that. And this now gives you the capability not only to survive a single node outage, or maybe 2 nodes, depending on how many replicas you've configured in the system, but also survive the failure of a single cloud region. Technically, we are not limiting anybody, so technically it could be even AWS, GCP, and Azure, if you wanted to. I mean, Ultimately, someone has to deal with the egress costs between the different clouds, but technically it's feasible, and we're seeing more and more customers asking for it for their most critical applications where their business is really hurt when downtime happens. So one takeaway here is that we basically allow you to distribute your database in an active fashion, so that should be kept in mind, that it's not like active here and maybe 2 passive copies or replicas in the other region. You can access the database in a read-write mode in all of the regions at the same time. And that means if one region fails, there is no, let's say, failover that you have to carry out at 2 a.m. in the morning. The system just continues to run. We require a quorum, so that means 2 out of 3 copies need to agree to a change before we commit back to the application. Hence, if one node or one region goes down, we're not talking about downtime, we're not talking about a failover. So literally an RPO, recovery point objective of 0, and recovery time objective of very close to 0. And the last key capability of CockroachDB, and I just need to check the time with somebody. Did I literally burn 20 minutes already? All right, I'll need to hurry up a little. All right, and one key thing, and that's one of the reasons why Ori is using CockroachDB under the covers, and why it's so great with identity and access systems, that you can be very granular. You can tell the system where certain data lives on a row level. And that now enables for identity and access management use cases, that my row, for instance, as user Patrick, lives in the EU, user Travis lives in the US, and a different or third user lives only in the APAC region. Oop, I think that was the wrong button. So gone are the days where you have to run multiple instances of the database for every region, or where everybody has to connect to the same place. That's gone. You basically distribute one database layer across the globe, having read and write access, and your data, or the PII data, for instance, pinned to one particular region. And to not stress time too much, that's basically how it would look like. One giant table. Your application thinks it's one giant table. Application has no clue about, let's say, the distribution or segregation we do under the covers. All US data would be distributed across US nodes, EU data across the EU nodes, etc. So you can literally push the same application, a consistent application across the globe, and not have to customize it here and there. All right, that's my wrap-up slide. I gone slightly over. So at the end of the day, Cockroach's multi-region capability enables definitely improved resiliency, low latency access, because data now lives where the user lives, no matter where it's on the globe. Compliance with things like GDPR and other stuff where I need to watch out where you're replicating data across the globe. Scalability, because now we can horizontally scale and push more performance or transactions through the system. And definitely lower operational efforts, because it's one system to maintain. And with that, I'll skip that one, I'm sure. You'll find our university, and there's even a blog by the Ori CTO. And thanks.